Thank you all for having me here this morning, talking about a little bit of introduction to concepts in artificial intelligence and machine learning in medicine. Why do we care, though? And what is it we're also interested in? Why did we show up this morning? Well, I'll tell you what it was. It's because we have a collective anticipation for the potential of emerging technologies now able to automatically answer questions previously thought to be impossible for a computer. Questions like, is that a chihuahua? Wait, I think it's a blueberry muffin. Technologies nowadays can automatically label every cat video on the internet and fill your Facebook feed with enough clickbait to keep you distracted for hours. And all while siphoning off your personal information, perhaps without you even realizing it's happening. Although it does make you wonder, perhaps there could be some more meaningful applications of this technology. How about, say, hey, is that a benign mole? Or is that a malignant melanoma? Is that cancer? More and more, you're going to see examples like these of automated systems that can answer clinical questions with superhuman levels of accuracy. And yet, medicine, healthcare, historically lags behind other industries by over a decade in terms of our effective use of information technology and our use of real-world data. Even though, wouldn't you think that medicine, the one place where literally lives hang in the balance, be the place where we should do this the best? Consider, for example, that by some estimates, medical error is the third leading cause of death in America. 250,000 dead every year. Now, some people argue, this number is nonsense, or this is ridiculous. Let's not exaggerate, people. It's more like 100,000 dead per year. So two things. Well, even if we're only 100,000, that would still be a jumbo jet airliner full of patients being pushed over a cliff to their deaths every single day. And more so, what I find especially concerning is precisely that we don't even know what this number is. Apparently, that is how much we care about reliably capturing and using our data in healthcare. I don't know, maybe lives are too abstract. Fine, then consider the ballooning costs of healthcare. Of the over $3 trillion we spend on healthcare every year, some estimates that are up to a third of that is essentially waste. It's services, it's administration, it's prices that don't even help anybody. So perhaps it is no wonder that many are looking for advancing technologies, intelligent systems that can help us make better use of our scarce healthcare resources to do more good for more people. So that's some of the why. We need to break down the what. What are we talking about? Is it artificial intelligence? No, you like machine learning, deep learning, no? Big data, precision health, cognitive, what are we talking about? When I think back to my PhD in computer science 10 years ago, I assumed we were talking about HAL 9000, Skynet, David for Prometheus, right? Thinking machines that can reason through complex problems, adapt to new situations, and fluidly interact with human beings. General AI systems, we are nowhere close to this type of technology, not even close. What are we talking about then? Nowadays, when someone is selling you AI, almost always what they're actually selling you is machine learning. It's a set of tools and techniques of which deep learning is just a particular subset. It's largely rebranded neural networks, been around since the 1970s, although in recent years has been shown to be particularly effective at certain tasks like image recognition. All right? If we break down machine learning a little bit more, there are many categories of the types of algorithms and applications that machine learning can handle. The common thread here is, unlike the classical approach where you program rules into a computer from the top down, instead these are algorithms that learn by example. They learn by data. Hey, I got 100 patients here with sepsis, a bad infection. I got 100 here who don't. Is it fever? Is it blood pressure? Is it, I don't know. Here, computer, just look at all of these examples and you tell me, you figure it out. You tell me what the rules are that makes them different. And even though there are many different categories, almost always what you're really usually being sold is supervised learning classifiers. It's actually a pretty narrow subset of these techniques. And bear in mind that these are not general thinking machines. These are models designed to answer very narrow multiple choice questions. Right? Is this a picture of a cat or is it a picture of a tumor? Is my patient going to have a stroke within the next year or not? Right? Commonly framed as prediction problems. Can you predict which of these answers to this multiple choice question is correct? Let's break down a concrete example to think this through, how this might work. I got a patient who came in to my emergency department, short of breath. I did a CT scan. Oh, shoot, pulmonary embolism, blood clot in the lungs, very dangerous situation. I'm gonna get this patient on blood thinners for treatment, but now I also have to make some key decisions. I gotta answer some questions. As a doctor, I have to make a prediction. Is this patient gonna be okay now? So that I can drive the decision, do I need to bring this patient into the hospital, or is it okay to just let him go home? Right? It's up to me now as a human being to make a prediction about what's gonna happen to this guy. So what am I gonna do? I'm gonna talk to the patient, I'm gonna examine him with these healer's hands and do my assessment, right? And based on my expert intuition, I predict he's gonna be fine. It's gonna be okay, don't worry about it, let him go home, you can trust me, I'm a doctor. And that's pretty good, actually. Expert intuition is very powerful. The challenge is it is very hard to reproduce, which means it is essentially impossible to deliver it at scale with consistency without some kind of support system. So what might be another approach? Well, how about let's use some data. If each one of these dots represents a patient who had a blood clot in the past, I measure their heart rate, I measure their oxygen saturation, and that's where they were. And the blue dots were patients where you treated them and they were fine. They went home and everything was okay. The red dots were patients where something bad happened. They ended up in the intensive care unit, or maybe they died. So when Mr. Green here shows up in your ER, what you can do is you can just draw a line through this data, a decision boundary in a mathematically optimal way that puts as many blue patients to one side and red patients to the other. Now I don't have to guess that much, because now in a quantitative way I can really assess, Mr. Green really looks more like a blue patient than a red patient. I feel much more confident in what I was already intuiting and letting him go home. Okay? Here's some many more examples. On the top left are several different input data examples, blue and red patients. And what's shown here is a battery of different machine learning algorithms, all looking at those examples and trying to figure out how to separate the world into red and blue spaces. What's worth noting here is that all of these examples, this is standard algorithms now, open source software. Any one of you could download and start using these tools right now. You don't need a PhD in computer science to start doing this work anymore. Combine that with the increasing ubiquity of electronic health data, and it now becomes possible, the time is ripe to start developing and deploying AI machine learning applications in healthcare and medicine. Before you dive in too deep, though, be aware of some things. This is different than a lot of the classical research you're used to. A typical observational research is all about inference. It's about explanation, explaining something about how the world works. I looked at the data, and smoking cigarettes totally causes cancer. Machine learning prediction algorithms, in general, they do not know, they do not care how or why anything works. Right? The only thing these algorithms try to do is optimize prediction accuracy, because that's the only thing you told them to care about. So don't be surprised then when the algorithm learns things like patients who are visited by the chaplain are very likely to die. This is absolutely true. This statement is absolutely true. If you're visited by the chaplain, that is highly predictive of death. Please don't conclude that firing the chaplain is a great way to save patient lives, right? Because you gotta understand the clinical context that the algorithm has no way to understand. You get that there's confounding by indication. The kind of patients the chaplain went to visit were the kind of patients who are in trouble, right? Other things you should think about. Remember, medicine, it is not a game and it is not a simulation, right? How come we have amazing advances in AI technology? We've got algorithms that can beat professional Go players. This is an amazing achievement. People have been trying for decades and could not do it. We've got self-driving cars. Why have we not solved medicine yet? I'm going to get to it already. The key distinction here is that we have no good way to simulate novel treatments for patients and to reliably know what the outcomes are going to be. If that's the case, how are you supposed to get data, information? How are you supposed to know what's going to happen? You got to run experiments. That's extremely expensive to do, and when you get it wrong, you kill people in very bad ways. All right? I'll actually disagree with the last point. I adapted this from a slide from Marty Tenenbaum about the data not being existent. I think actually a lot of the data we want does exist, but it's locked up in healthcare system silos who have no incentive to want to share it. And even if you could get access to it, it is notoriously messy and difficult to deal with, because healthcare data was not created for the purposes of, improving healthcare. It was created for the purposes of billing or for ad hoc communication. Just bear that in mind when you consider where we are on the hype cycle of emerging technology. Notice what is at the tip top of the peak of inflated expectations right now. It's machine learning, it's deep learning, it's AI technology, right? So what I'm really hopeful for is at a conference like this, is that together with the discussion, we can foster a better appreciation for the limitations, the capabilities, and the implications of such advancing technologies, so we can soften our subsequent crash into the trough of disillusionment and quickly move on to the slope of enlightenment, where we consistently use every information and data source to effectively improve our collective health. Thank you, everybody.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.